Hello and welcome to this podcast series recorded by me, Ed Langley, Engineering Manager at Wittekio, in collaboration with Martin Lesniak, Applications Engineer at STMicroelectronics. This series of 5 podcasts is dedicated to understanding ST's STM32MP1 microprocessor offering. Enjoy.
You mentioned there about the heterogeneous architecture where you've got the A7, you've got the M4, possibly 2 of each. There's a few sort of examples out there that you see from vendors where they might show a demonstration of a sort of heterogeneous software architecture system using such a combination of processors where they might run, for example, Android on the larger A7 cores, and then with asymmetric multiprocessing they run a different OS on the smaller CPUs, so in this case the M4s, for, as you mentioned, real-time or safety critical tasks. Do you, ST, have any kind of official support for that, or have you seen any such setups on the MP1?
Yes. So short answer is yes. And according to, at least the numbers I've looked at, there's at least 50% of users out there, and I think that's a pretty conservative figure from the experience I've had, at least in the United States, where folks do use it in that mode. They separate the tasks of what happens on the M4 side versus the A7 side, and of course the M4 side in some instances runs even bare metal. In some instances customers utilize some kind of an RTOS. There are a couple that we offer for this device, and so at least it's a good starting point. But at some point, as I mentioned, these things have to communicate. So there is definitely an infrastructure, both from a software perspective and a hardware perspective, that allows that intercommunication to happen. And our strategy has been to utilize, standard practices for this and standard software components. For instance, things like OpenAMP.
Okay.
Part of that runs on the M4, and of course, there's a framework that's compatible with OpenAMP that runs on the A7 side. Hardware we do utilize very specific hardware blocks to make that exchange as efficient as we possibly can. Things like hardware semaphores, things like interprocessor communications controller. So all of those solutions, all those hardware solutions kind of augment what the software does. And the fact that the coprocessor is an M4, traditionally a lot of industrial type applications or very time critical applications such as motor control and maybe even some things on the medical side as well. There's a lot of STM32 F2 and F4 family devices which have been used out there. And if the designers, if customers used ST tool sets for this, for that development, because the MP1 is covered by a very similar tool set, at least from the M4 perspective, the porting of that code may be a little bit easier for someone, where they can just port it from an F3 or an F4 to the Cortex M4 within the MP1.
Interesting. Okay, so it's like a convenient sort of upgrade path there.
Yeah, and it's one of these things where, again, to me, the peripheral set in this device to a large extent, looks like a microcontroller. And there's a fair amount of peripheral sharing. So again, we try to architect it so that software migration from a standard Cortex, let's just say Cortex M device, to the MP1 Cortex M portion, we try to make that as easy as possible.
That was flexible architecture for combined HMI and real-time operation, a podcast by Witekio in collaboration with STMicroelectronics. Watch out soon for the 5th and final episode in this series, running Linux on the STM32MP1.